students. Thank you for encouraging my video. Previously, I have done formulas marathon. Now, I'm doing theory marathon for CA Foundation. I will do it in two parts. In part one, I will cover 50% of the syllabus. That means MCT, MOD, statistical description of data, and sampling. These 4 chapters will cover 20 marks. Okay. Out of 40 marks in stats, these 4 will come with 50% of the marks, that is 20 marks. Now I will start the theory part 1. Okay. Firstly, statistical description of data theory. So, what is meant by data and what is meant by variable? Data means set of numerical factors. Set of numerical factors is always considered as data, and single value of any data is known as data. So now variable, measurable quantity is known as variable. You all know that non-measurable is considered as attribute and measurable quantity is variable. Out of these variables, there are 2 types. One is discrete variable, which assumes only finite or countable infinite isolated values. That means not decimals, discrete values. A variable which assumes only discrete values. That means integer values without decimals. That is discrete variable. Examples: number of petals in a flower, number of road accidents, number of printing mistakes in a page, number of students in a class, etc. Next, continuous variable. When a variable can assume any value between certain limits in an interval, that means either integers or decimals, that variable is known as continuous variable. Examples: height, weight, sales, profit, etc. Next, attribute. Non-measurable characteristic, that is qualitative characteristic, is known as attribute. Quantitative means variable, qualitative means attribute. So non-measurable characteristic, example: gender, nationality, color, taste, etc. These are will considered as attributes. Next, data. Quantitative information shown as numbers are known as data. Data means group of values, not a single value. Group of values is known as data. Data means a single value. That means data is plural and data means singular. Data means the smallest part of our data inquiry. Next. Next. History of statistics. Where from the origin? Where from the statistics word have been come? That is the origin. It was come from Latin word status, Italian word statista, German word statistic, and French word statisticu. This is very important part. You have to remember these 4 words: Latin word status, Italian word statista, German word statistic, and French word statisticu. Statistics can be defined in both singular sense and also in plural sense also. In singular sense, statistics can be defined simply as scientific methods which are used for collecting, analyzing, presentation, and interpretation of the numerical data. That means in singular sense, scientific methods is known as statistics. In plural sense, statistics is defined as numerical data. Either it may be a qualitative or quantitative data. If you have any data, numerical data is considered as statistics in plural sense. Next, how can we collect data? We have 2 methods for collecting data: primary data and secondary data. What is meant by primary data? The data which are collected for the first time by an investigator. That means the investigator himself is responsible and he will go to the field and he will collect the data. That is known as primary data. Secondary data. Investigator himself will not go to the field, but some other person may have been collected the data and the investigator is using that data for his purpose. That means it is known as secondary data. Okay, primary data will be the reliable in nature. If you have no time, you can opt for secondary data. How to collect primary data? How many methods are there? For primary data collection, there are different methods like interview method, mailed questionnaire method, observation method, questionnaire sent by enumerators. Interview method. There are again 3 methods. Direct personal interview. In this method, directly the investigator will go to the respondent and interview him and collect the data. So this is the best way of collecting the data and you can obtain the reliable information. When to use this method? This is a very important point. In the case of natural calamities like earthquakes, floods, we will go through direct personal interview method. Next, indirect personal interview. If you have no time and if the person is not available from whom you are going to obtain the data, that person is not available. In that cases, your data will be obtained from third person. Here, first person means investigator, Second person means the respondent, that means from whom you are collecting the data, and third person is a third party person. Okay, so from third person you are collecting the data, that means indirect personal interview. This method is used in the case of accidents. That means when an accident is done, the person may be available or he may be in hospital in serious condition, but you have to obtain the data of him. Then any one person who knows about him will give you the information. That is the indirect personal interview. So in the case of accidents, best method is indirect personal interview. Telephone interview is the quickest method for collecting the data. Okay, so these are the main points. For natural calamities, direct personal interview. For accidents, indirect personal interview. The quickest method of data collection is telephone interview. And next, mailed questionnaire method. So in this method, questionnaire is sent through post and ask the respondents to fill the data, and like that through post we are collecting the data. It covers wider area, but there are chances of non-response for this method. That means all the persons may respond or may not be respond. So chances of non-response are more for mail questionnaire method, and covering wider area, that method is mail questionnaire. Next, observation method. Just by observation, that means by measurements you are collecting the data, that is known as observation, by measurements or through observation. Next, questionnaire sent by enumerators. Mostly this is the reliable method. In questionnaire, mailed questionnaire method, we are sending the questionnaire through post, but there is high chances of non-response. To avoid that one, questionnaire is sent through enumerators, where the enumerators are the trained persons which are meant for collecting the data. So we appoint some enumerators by training them to collect the data, and questionnaires are sent through them and they will collect the data. Mostly census method is applying this method. That means again this method is nothing but direct personal interview. So overall the reliable method is direct personal interview or mailed sent by questionnaire sent by enumerators. This is how we can collect primary data. Next, secondary data. What are the sources of secondary data? Already some person have collected the data and they may publish or unpublish that type of data. So there are two sources for obtaining secondary data: published sources, unpublished sources. Published sources means international sources like WHO, World Health Organization, International Monetary Fund, International Labour Organization, World Bank, etc. From these organizations, we can collect the international data. Similarly, from central and state government publications also you can obtain the data, like Central Statistical Organization data, NSSO, National Sample Survey Organization, RBI, SEBI, IRDA, etc. Similarly, there are some private or quasi-government sources like Indian Statistical Institute, Indian Council of Agriculture, NCRT, Rotary clubs like that, Red Cross, etc. Okay. These are known as published sources, and sometimes research papers, research scholars will also obtain some data, and they may be also useful for us. So from the research papers and other unpublished sources also you can collect the data. These are the various sources of secondary data. So first phase of statistics is collection of data. After collecting, the second phase is scrutiny of the data. Data may be collected by different persons in different ways. Finally, you have to check for accuracy and consistency of the data. That is known as scrutiny. So scrutiny means checking for accuracy and consistency of the data. Finding any errors by enumerators while filling or receiving questionnaire, that can be avoided by scrutiny. Okay, when there are two or very third point is important. Internal consistency means when there are two or more series of related data in your data collection, then it can be checked by internal consistency. So when two or more series of related data are given, then we have to go for internal consistency. So second phase is internal consistency of data. After second phase, our third phase is classification. After collecting the data, data can be divided into various subgroups based on similarities. That is known as classification. Classification makes comparison very easy, and classification makes presentation very easy. So classification means dividing the data into various subgroups based on similarities. So there are four types of classification. First one is chronological or temporal or time series. If the data is divided based on time, okay, that is known as chronological classification. If your data have been divided based on regions or places or based on countries, states, nationalities like that, it is known as geographical or spatial series. Okay. Qualitative classification. If your data is divided based on non-measurable characteristics, attributes, then that type of classification is known as qualitative or ordinal data. Okay. Similarly, Fourth type of classification is quantitative or cardinal data. That means data is divided based on variables. That means discrete variable or continuous variable. That means measurable characteristics based on heights or based on weights, based on marks. You are dividing the data. That means quantitative. I will give a small example for all these four types. If the data is divided based on years and date of joining, okay, year coming to college, based on years you are dividing, based on date of joining you are dividing the students. That means it is temporal classification. Based on regions, all the students may have come from different regions. Based on regions you are dividing the students data. That is known as geographical data. Based on color or based on caste, based on marital status or based like that attributes, that is known as qualitative. Similarly, based on heights or based on marks you are dividing the number of students, that is known as quantitative. So four types of classification. Examples will be given, Nana. So concentrate on examples. Okay. So next, fourth phase of statistics is presentation of data. How to present the data? So there are three modes of presentation: textual presentation, tabular presentation, and diagrammatic presentation. What is meant by textual presentation? If you are presenting your data in the form of descriptive manner like paragraphs, it is known as textual presentation, and it is the least form of presentation. That means this type of presentation cannot be understood by all the people. You have to study it. Uneducated people cannot understand what you are going to present. So textual presentation means you are presenting your data in the form of descriptive manner like paragraphs. Tabular presentation, second one is tabular presentation or simply tabulation. It is the appropriate way of presenting the data. That means you are presenting your data in the form of rows or columns, in the form of a tables. So appropriate way of presenting data, very important point. Appropriate way of presentation is always tabulation. Table consists of 5 parts. One is table number and title. Second one, stubs and captions. Third one, box head. Fourth one, body of the table, footnote. Okay. First part is table number and title. Every table will have some title and sometimes table number also. Next, what is meant by stubs? Stubs means left part of the table which describe about rows. So stubs or rows are arranged left side of the table. Caption means columns. Upper part of the table which describes about columns or subcolumns is known as captions. And next, the entire upper part of the table is known as box head. Box head means entire upper part, row headings, column headings, all the upper part, table headings. That means the total upper part of the table is box head. Sometimes you may have to express some unit of measurements based on your data. That units will also be expressed in box head only. So units of measurements are expressed in box head. Source of data is expressed bottom of the table, and a footnote means also bottom of the table. So these are the 5 parts of the table. So you have to remember these points. Left part of the table which describes about rows is stubs. Upper part of the table which describes about columns and subcolumns is captions. Entire upper part is box head. Units of measurements is expressed in box head only. Source note or footnote is expressed at the bottom of the table. Okay. So third type of presentation is diagrammatic presentation. If you have to present your data in most attractive way of presentation is diagrammatic presentation. That means you are presenting your data in the form of diagrams, pictures, graphs, etc. Okay. So that is known as diagrammatic presentation. What is the main use of diagrammatic presentation? Means hidden trend can be easily identified by diagrammatic presentation. Hidden trend means you can observe whether the data is increasing or decreasing or it is behaving in a constant manner. That is known as trend. Hidden trend can be clearly obtained by diagrammatic presentation. Okay. So there are different types of diagrams, Nana. So coming to types of diagrams, there are non-frequency diagrams and frequency diagrams. Non-frequency diagrams means will be no frequencies, individual series. Frequency diagrams means for discrete and continuous series, we will express them in the various type of diagrams. Okay. Non-frequency diagrams, in that one, first one is line diagram. It is a one-dimensional diagram. Line diagram is a one-dimensional diagram. So it is best diagram for time series data. That means chronological data. In line diagram, for every diagram, please remember the x-axis and y-axis. Coming to line diagram, our x-axis will be the time and y-axis will be the time series variable. Okay. So what are the important points in line diagram? See here, plotting the points in graph and join them to make a line. We will plot a points and join all the points, then you will get a line diagram. So other name for line diagram is also known as histogram. Okay. So line diagram is used generally for time series. Variable y is plotted against time t. That means x-axis is time t and variable y is time series value is y-axis. Okay. So for wide range of fluctuations, if there are wide range of changes in your values, in that case, you have to take logarithms. That type of chart is known as logarithm chart or ratio chart. That means x-axis will be time and on y-axis log y is taken. That is ratio chart. For wide range of fluctuations, ratio chart is used. If there are two or more time series and all are having same units, then you will go for multiple line chart. And if you have two or more time series with different units, then you will go for multiple axis line chart. These are the main points in line diagram. You have to remember line diagram is a one-dimensional diagram. After line diagram, bar diagram. Okay, bar diagram is also one-dimensional diagram, Nana. Just we will go with the height of the bars only. So length or height is the only one factor considered here. So bar diagram is one-dimensional diagram. In bar diagram, there are two types, horizontal bar and vertical bar. When to use horizontal bar? For qualitative classification or spatial classification, you go for horizontal bar. For quantitative or chronological, that means time series, you go for vertical bar diagram. Very important point. Horizontal bar meant for qualitative or spatial, vertical bar meant for quantitative or temporal. Bar, what is meant by bar? Bar means rectangle of the same width but of varying lengths. Lengths may vary, but width may not vary. So it is a one-dimensional diagram. Okay. So horizontal or vertical, based on your data, horizontal bar or vertical bar you have to use. For comparing different series, you have to use multiple group bar or multiple bar diagram or grouped bar diagram. For data divided into multiple components, subdivided or component bar diagram you will use. For relative comparison to the whole, percentage bar diagram or subdivided bar diagram. Very important point. So we are comparing each value with respect to the total. So for comparing to the whole, percentage bar diagram or divided bar diagrams are used. Last point is important here. For a characteristic which has two opposite factors, we use slided bar diagram. In recent exams, he was concentrating on slided bar. If a variable has two opposite factors like literate, illiterate, skilled, unskilled, censored, uncensored, cured, not cured, for that type of data, you have to go for slided bar diagram. So this is about bar diagram. Okay, please remember the points. And the point important here is when you have to compare each component with respect to the total, then which diagram we are going to use? Subdivided bar or percentage bar. Okay. After bar diagram, next diagram in non-frequency diagram is pie chart or pie diagram. Okay. So which is a two-dimensional diagram, Nana. Pie diagram is a two-dimensional. That means we are considering both breadth and also width. Okay, length and width. So pie diagram is used for circular presentation of the relative data. That means again, percentage of the whole. We are comparing each component with respect to the total. Nana, please remember this point. When you are interested to compare each component with respect to the total, we can use three types of diagrams. Already discussed. Subdivided bar diagram, similarly percentage bar diagram, and now pie diagram is also used for the same purpose. Specifically, pie diagram is used for cash flows. If your example is based on cash flows, that means cash expenditures, incomes, budget, shares, 5-year plans, like that. Okay, sources of income. For all this type of data, you have to use pie diagram. In pie diagram, you have to remember this formula, central angle or segment angle, where the formula is segment value by total value into 360. Okay, this is how non-frequency diagrams will be. Okay, next I will go with frequency diagrams. Before going to frequency diagrams, I will explain what is meant by frequency distribution. What is meant by frequency? Frequency means number of times a particular observation is repeated. Okay, this applies to both variable and also attribute. So how many types of frequency distributions are there? We have two types. One is discrete frequency distribution and other one is continuous frequency distribution. Discrete frequency, other name is simple frequency distribution or ungrouped. Continuous frequency is also known as grouped frequency distribution. Okay, coming to frequency distributions, continuous frequency, we have two types, inclusive series and exclusive series. For that purpose, you have to remember some important terms. Mutually exclusive classification or overlapping. Exclusive series or overlapping series. What is meant by exclusive series? If our upper class boundary of any class is equal to the lower class boundary of the next class, it is known as exclusive series. Please see the points. This is usually applicable for continuous variable. Continuous variable, exclusive series. An observation as UCL is excluded from the class interval are taken in the class where it is LCL. Suppose 0 to 10 and 10 to 20 is there. 10, the value 10 is not occurred in the first class. That means upper limit of the first class is excluded and is included in 10 to 20 in the next class. Upper limit is excluded for exclusive series. Okay, upper limit is excluded for exclusive series. So an item whose value coincides with the upper limit of a class is excluded from that class. Okay, and included in the next class. Similarly, lower limit is included and upper limit is excluded. Okay, lower limit 0 to 10. 0 is included in that class, but 10 is excluded. Lower limit will be included and upper limit is excluded. That type of series is known as exclusive. Upper limit of one class is the lower limit of the next class, 0 to 10, 10 to 20. Upper limit of the one class is equal to the lower limit of the next class, exclusive series. I have given an example, Nana, 10 to 20. Class where 20 will fall. It will not fall in the first class. It will fall in the next class, 20 to 30. Upper limit is excluded and it is included in the next class. Only lower limit of that class is included in that class and upper limit is excluded. That is exclusive series or overlapping series. Next, coming to mutually inclusive or non-overlapping inclusive series. Inclusive series means what are the main points you have to remember? Every class upper limit will not coincide with the lower limit of the next class. Suppose 10 to 19, 20 to 29. 19 and 20 are not equal. That series is inclusive series. So in this inclusive series, both lower limit and upper limit, both are included in the same class. That means 10 to 19 means if there is 10 in the value and 19 also in the value, both limits are included in the same class only. That is known as inclusive series. So both upper and lower limits are included in the class interval. Upper limit of one class is less than the lower limit of the next class. 10 to 19, 20 to 29. 19 is less than 20. Okay. Upper limit of one class will be less than the lower limit of the next class. Similarly, it is used in the case of discrete variable. So always inclusive series is meant for discrete variable, Nana. That means there will not be decimal values. But for continuous variable, always you have to use exclusive series. Exclusive series means overlapping series. Inclusive series means non-overlapping series. Now, what is meant by class limits? Lower value of any class interval is known as lower class limit. Upper value is known as upper class limit. LCL is lower class limit. Upper UCL means upper class limit. Okay. So coming to inclusive series, Nana, 10 to 19, 20 to 29, 30 to 39. This is known as inclusive series. So here 10, 20, 30 are LCLs and 19, 29, 39 are known as UCLs. 19, 29, 39 are known as UCLs. So here. Okay. Similarly, coming to exclusive series, 10 to 20, 20 to 30, 30 to 40. This is exclusive. 10, 20, 30 are LCLs and 20, 30, 40 are UCLs. Similarly, next one is class boundary. Coming to class boundaries. What is the difference between class limits and class boundaries? Class boundaries are always true class limits of the classes. Class boundaries are always true class limits and actual class limits. So coming to exclusive series, both limits and boundaries are equal. There is no difference. For exclusive series, class limits and class boundaries both are equal. But for inclusive series, class limit is not equal to class boundary. You have to convert class limits into class boundaries. Inclusive series is converted to exclusive series. All of you know that point. Okay. So d by 2, subtracting d by 2 from lower limit will give your LCB. LCB is LCL minus d by 2. UCB is UCL plus d by 2. So you can convert class limits into class boundaries. This is how inclusive can be converted to exclusive. So class limits means always meant for inclusive series. Class boundaries exclusive. Coming to exclusive series, class limits and boundaries are equal. But for inclusive, limits and boundaries are different. Okay. So now, how to calculate the mid value of the class? Lower limit plus upper limit by 2 or lower class boundary plus upper class boundary by 2. You know all that one. Okay. Similarly, but for finding the width of the class or size or length or magnitude, you have to consider the difference between boundaries only. That means always for exclusive series only, you have to find the width. Okay. Please remember that point. Number of class intervals. Already I have discussed this in formula marathon also. But sometimes some formulas are important for theory also. So only I have included some formulas here. Okay. Number of classes. K, range by width of the class. Number of classes. K equal to 1 plus 3 plus 1 plus 3.332 log n. Okay. Next, what is meant by cumulative frequency? It is defined as the number of the observations less than or greater than particular value. Cumulation frequency means, cumulative frequency means we are going to add the frequencies. So LCF and GCF. Less than cumulative frequency means you are adding frequencies from lower class to the higher class. Greater than cumulative frequency means we are adding frequency from greater class to the lower class. LCF meant for frequencies adding in ascending order, and GCF is going to add frequencies in descending order. Top to bottom is LCF, bottom to top is GCF. Okay. Next, frequency density formula is frequency by class length of the class, and relative frequency means frequency by total frequency. This is about frequencies. Now I will go with the frequency diagrams. Nana. So frequency diagrams are also considered as graphs. So first one is histogram or area diagram. For constructing histogram, our x-axis will be the class boundaries and y-axis will be the frequencies. That means for histogram, always exclusive series must be taken. Always exclusive series must be taken. Okay, class boundaries only, not class limits. X-axis class boundaries, y-axis frequencies. So exclusive series, histogram. Always histogram is meant for exclusive series only, and histogram is used to find mode also. In histogram, rectangles are drawn, Nana. So rectangles are drawn. Bar diagram also we are going for rectangles, but there is gap between rectangles in bar diagram. But coming to histogram, there will be no gap, overlapping. Okay, all the rectangles will be overlapping in histogram. Histogram is drawn for equal class width or also unequal class width. Unequal class width should be converted to equal class width. Then you can draw the histogram. Okay. So coming to equal class width, histogram, each rectangle is proportional to frequency of that class. Equal class width means all the rectangles are proportional to frequency of that class. If all classes are unequal, unequal class width means our rectangles are proportional to frequency density. Please remember this point. Equal class width means all frequencies are proportional to class frequencies. Unequal class means all rectangles are proportional to frequency density. The sum of values of all rectangles will be equal to total frequency. So only histogram is also known as area diagram. So histogram is known as area diagram. Sum of all class frequencies will be equal to total frequency. Width of each rectangle in histogram is equal to class width of that class. And a width is equal to class width. And height of the rectangle is proportional to class frequency if it is equal width. And class frequency if it is equal width. Frequency density if it is unequal width. These are the important points in histogram, Nana. So histogram or area diagram, both are equal. It is always meant for exclusive series only. Next, frequency polygon. For constructing frequency polygon, on x-axis you have to take mid values, and on y-axis you have to take frequencies. So x-axis is mid values and y-axis is frequency. For each mid value, we will plot frequencies and join all the dots. That will give your frequency polygon. Frequency curve also covers the same point. If you are joining all the successive points, that means all the frequencies of the mid values with a ruler, it will give frequency polygon. If you are joining all these points with a freehand curve, it is known as frequency curve. Okay. So if the
how many types of frequency curves are there? We have 4 types. So frequency curve is a smooth curve which is drawn by taking mid values on x-axis and class frequencies on y-axis. All the points are joined with a smooth curve, and there are 4 types. One is bell-shaped curve. Most of the distributions follow bell-shaped curve, where in this bell-shaped curve the frequency starts with minimum and reaches maximum at the center and again reaches the minimum. That means minimum at extremes and maximum at center. That is bell-shaped curve. So most of the distributions will follow bell-shape. And next one is U-shaped curve. This is opposite to bell shape. That means at extremes it will be maximum, and at center it will be minimum. That means U-shaped curve. Okay. Next one is J-shaped curve. That means the frequency starts at minimum point and reaches at maximum and stops there. It occurs like J-shape. Okay, J-shaped curve. And mixed curve is combination of all the curves. So there are 4 types of frequency curve. Mostly used is bell-shaped curve. So in diagrammatic presentation, the last type of presentation is Ozai curve. Okay. And it is also known as cumulative frequency graph. On x-axis, that is on abscissa, we will take class boundaries, and on y-axis consider cumulative frequencies. So only this is diagram is known as cumulative frequency diagram. Okay. So already you know that there are 2 types of cumulative frequencies: less than cumulative frequency LCF and more greater than cumulative frequency GCF. So there are 2 types of Ozai curves, LCF and GCF. So by plotting on x-axis, if you have considered UCBs, and on y-axis, if you have considered cumulative frequencies, you will get less than Ozai curve. And for greater than Ozai curve, our x-axis will be LCB, lower class boundary, and on y-axis cumulative frequencies. So the intersection point of 2 Ozai curves is known as median. So by using Ozai curve, you can calculate median value by using graph. Not only median, you can also find partition values like quartiles, decays, octiles, percentiles, like that. If you draw only one Ozai curve, n by 2 coordinate will give your median value. That means corresponding to n by 2 coordinate, if you have drawn a perpendicular line to abscissa x-axis, then it will give median. N by 2 coordinate is median. N by 4 coordinate is first quartile. 3n by 4 coordinate is third quartile. And similarly, kn by 10 coordinate will give your kth decile, and kn by 100 coordinate will give your kth percentile. So by using Ozai curves, you can calculate median as well as all the partition values. So this is about first part. Okay, first chapter, statistical description of data. So main points you have to remember is primary data, secondary data, and classification of data. That means there are 4 types of classification. Okay. If CA students appearing year-wise data is given, it is chronological data. If CA students appearing region-wise or state-wise or district-wise, that is known as geographical data. If CA students based on gender-wise, boys, girls, like that, it is qualitative data. If CA students based on heights or weights, like that, it is quantitative data. So please consider, please focus on the examples, Nana. Please understand the concept clearly. Okay. Now I will move to the second chapter, measures of central tendency. Okay, what is meant by central tendency? A central tendency is a single value which represents the entire data, and that value will be exactly at the center. So it is known as measure of central tendency. That means data cluster around a central value. Cluster, central value, all these are the synonyms of central tendency. Central tendency is also known as average. Okay, averages are 5 types, whereas central tendencies are 3 types. Central tendencies means we have to say mean, median, and mode only. Averages means again mean is divided into 3 types: arithmetic mean, geometric mean, harmonic mean, and after that median and mode. So averages are 5 types, whereas central tendency is only 3 types. Similarly, average discovers uniformity in variability. Various values, we are finding a uniform value as a representative. So average measures uniformity in variability. Measures of central tendencies are known as averages of first order. That means why? First of all, if a data is given, we have to calculate first averages only. So central tendencies are known as averages of first order. In that, first one is arithmetic mean. Arithmetic mean is a mathematical representation of the typical value of the series of numbers computed as the sum of all the numbers in the series divided by the count of all values, summation x by n. So mean formula for individual series is summation x by n. By using this formula, you can also find sum of the values. Very important one, that is n into x bar. Summation x is n into x bar, sum of the values. Even mean can also be calculated by using assumed mean method, where the formula is a plus summation d by n. Okay, and it can also be considered as x bar equal to assumed mean plus d bar. That means average of the deviations. Assumed mean plus average of the deviations is mean. That is assumed mean method. So for discrete series, when there are frequencies, or continuous series, when also there are frequencies. So there are 2 types of frequencies: discrete series and continuous series. The formula for calculating mean is x bar equal to summation fx by summation f, which can also be considered as Catalan total frequency. Combined mean. If you have 2 or more data, And for two data, we have means as x1 bar for the mean of the first data and x2 bar mean of the second data. And there are n1 and n2 values in both the data values. Then combined mean can be given by n1 x1 bar plus n2 x2 bar by n1 plus n2. Okay. Now, what are the main points you have to remember in mean? Sum of deviations from mean is always 0. Sum of algebraic deviation, summation x minus x bar is always 0. Okay. So sum of deviations from AM is always 0. Very important point. Similarly, sum of squares of the deviations from mean is minimum. If you take sum of squares of deviations from mean, median, mode, etc., always sum of squares of the deviations will be minimum at mean only. Arithmetic mean is affected due to both change of origin and scale. Even if the data is increased or decreased, the mean will also change. Even the data is multiplied or divided, mean value will also change. That means it is dependent on both origin and scale. So arithmetic mean is greatly affected by extreme values, and it is not suitable for open-end data. Since we have to find mid values, so it is not suitable for open-end data. Arithmetic mean is not better measure for open-end data. It is least affected by sampling fluctuations. That means sampling stability is more. That is about mean. Next, coming to median. Median is the middle item and it divides the data into two equal parts. So the average which is dividing the data into two equal parts is median. So for ungrouped data, that is for individual series, median formula is n plus 1 by 2th term. Okay. So the formula for median in the case of individual series is n plus 1 by 2th term. After rearranging the observations, you calculate median. Okay. Similarly, in the case of even number of values, so if n is even, median formula is nothing but size of n by 2th term plus n plus 1 by 2 n by 2 plus 1th term, or n by 2 plus n by n plus 2 by 2th term, like that. Okay. Median can be calculated. For discrete data, median is n plus 1 by 2th term. For continuous series, you all know the formula L plus n by 2 minus CF by F into C. Okay. I have explained all these in the formula method. Okay. Now, again, next, other partition values are quartiles, decades, percentiles. We have three quartiles, Nana. Q1, Q2, Q3. That means quartiles divides the data into four equal parts. Okay, now four equal parts. There are three quartiles. Second quartile is nothing but median value. Okay. Again, coming to decades, there are 9 decades, D1, D2, so on D9, and decades divides the data into 10 parts. Fifth decade is known as median value. So this is the main point. Fifth decade is nothing but median value. Similarly, percentiles, we have 99 percentiles and 100 equal parts. Okay, 58 percentile is the median value. So relation between quartile, decile, percentiles are the main ones. So for example, 10th percentile is equal to first decile, 20th percentile is equal to second decile. Similarly, coming to the first quartile, it is also equal to 25th percentile, like that. Okay. So important points for median. So median can be found by graph by using Gaussian curve. Already we have discussed that point. The intersection point of two Gaussian curves or n by 2 coordinate in an Gaussian curve is nothing but median. Not only median, you can also find quartile, decile, octiles, percentile by using Gaussian curve. Median is not a good representative of the data if the number of items is small. Okay. Median can be calculated even in the case of open-end series. For open-end data, mean is not better measure. In that case, median is the better measure. So median is not based on all items. It is not affected by extreme values. Sum of absolute deviations from median is minimum. This is important point. Sum of absolute deviations means we are considering the deviation. If you neglect the negative sign, those deviations are known as sum of absolute deviations. So sum of absolute deviations. So they are, when they are taken from median, they will be minimum. So median divides the data into two equal parts. Okay. Median divides the data into two equal parts. Now that means the values less than or equal to median are equal to the values greater than or equal to median. So this is about median. Next, mode. Mode is nothing but the repeated value. It is the size of that item which causes the maximum frequency. Okay. So the value of the variable which occurs most frequency in a distribution is called mode. So So in continuous series, you know the formula for calculating the mode. Okay. So what are the important points to remember in mode? Mode can be determined by graph using histogram. Okay. It is not affected by extreme values. It is used in open-end case also. But for open-end, median is the best measure. Please remember that point. For qualitative data, you can use median and mode. Median is the best measure for qualitative data. It is not useful for further algebraic treatment. It is not based on all items. It is not rigidly defined and not fulfill most of the requirements of good measure of central tendency. Not rigidly defined means mode can be bimode, trimode like that. Okay. So it is not rigidly defined. It is not a good measure of average. Okay. So what is the relation between mean, median and mode? So mean minus mode equal to 3 times of mean minus median, or mode equal to 3 median minus 2 mean. It is this relation is known as empirical relation, and this relation holds for moderately symmetric. That means it is not purely symmetric or it is not purely asymmetric. If it is symmetric, the relation between mean, median and mode is mean equal to median equal to mode. Symmetric means mean equal to median equal to mode. If it is moderately skewed, now we have discussed the relation mean minus mode equal to 3 times of mean minus median, or mode equal to 3 median minus 2 mean. If it is positively skewed, mean is greater than, median is greater than mode. Negatively skewed means mean is less than, median less than mode. Okay. Next, coming to geometric mean. So geometric mean is based on all observations, and it is difficult to understand, not so simple. Logarithm of GM for set of observation is arithmetic mean of logarithm of the values. This is important point. Log GM is nothing but summation log x by n. So arithmetic mean of logarithm of the values. If z equal to xy, then GM of z equal to GM of x into GM of y. So GM is useful for averaging rates, ratios, and percentages. Especially for average rate of increase, average rate of decrease, we have to use GM. It is capable for further mathematical treatment. That means combined GM is also there. Formula anti-log of n1 log GM1 plus n2 log GM2 by n1 plus n2. If any item is negative or 0, GM cannot be computed. If any item is 0, GM will be 0. If any item is negative, we can't compute GM. Okay. That next, harmonic mean. Harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocal of the values. Okay. So that means in individual series, you know the formula HM equal to n by sum of reciprocals, n by summation 1 by x. Okay. So it is based on all observations. It is also not easy to compute. That means we have to calculate the reciprocals. So it is not so simple compared to mean, median, and mode. That means AM, median, and mode. Okay. GM and HM are not easy to compute. It is more suitable average for measuring time, speed, etc. Average time, average speed, like that. Okay. It is also used for rates and ratios. If any observation is 0, HM cannot be computed. If any value is negative, GM cannot be computed. If any observation is 0, HM cannot be computed. HM is useful for average rates, ratios. Okay. Average speed, average price, like that. Even though we have combined HM, that means HM is also used for further mathematical treatment. Combine HM n1 plus n2 by n1 by h1 plus n2 by h2. Now, what is the relation between AM, GM, and HM? So, if all the observations are equal, for that type of data, AM is itself the given value. That means if all are 100, AM is 100, GM is 100, HM is 100, even though median is also 100. But mode, whenever all the values are equal, mode cannot be defined. Please remember that point. That means all measures of central tendency, if all values are equal to K, all measures of central tendency except mode, AM, GM, HM, median will be equal to K, but mode is ill-defined. Okay. Now, for any two values, what is the relation between GM, AM, and HM? GM whole square equal to AM into HM. For only two values, this relation will hold. So what are the important points to remember here? In case of rates like speed, hours per easy, which average we are using? HM. In case of percentages and ratio, GM is used. Okay. Average rates and ratios means GM and HM both are used. If it is the case of percentages, only GM is used. Okay. Generally, AM is greater than or equal to GM is greater than or equal to HM. In general relation. Suppose if all values are equal, already we have told that AM equal to GM equal to HM. For distinct values, if all values are different, AM is greater than, GM is greater than HM. So best measure over all measures of central tendency is always arithmetic mean. Best measure for open-end class is median. Based on all observations, AM, GM, and HM. Based on 50% of the values is median. Least affected by sampling fluctuations is always AM. Rigidly defined, easy to comprehend is AM, median, GM, and HM, but mode is not rigidly defined. No mathematical property means median and mode. Further mathematical property, combined property is not for median and mode. Extreme values effect is greater in AM and not for median. Extreme values effect is not for median. Not affected by extreme values is median, but greater effect is AM. Okay. This is about central tendency, Nana. Next, dispersion. What is meant by dispersion? Dispersion means for a given set of observations, amount of deviation or amount of variation or scatterness, deviation, variation, volatility, all these means dispersion. That means we already computed central tendency average value. Now we are measuring the deviation of each value from central tendency value, that is known as dispersion. So dispersion are known as averages of second order. In central tendency, for the given data, you have found a representative value. That means it is known as uniformity in variability. Coming to dispersion, already uniform value is there. Now we are finding the deviation. It is known as variability in uniformity. So dispersion means variability in uniformity, and dispersion are known as averages of second order. We have two measures of dispersion: absolute measures, relative measures. Absolute measures of dispersion means range, MD, SD, QD, and variance. Relative measures, all the coefficients. Okay. So difference, what is the difference? Absolute and relative. Absolute measures are dependent on units. If the data is given in centimeters, all absolute measures, range, MD, QD, SD, and variance. The units, sorry, for variance, it will be square anyway. Absolute measures are dependent on units. Whereas relative measures, there are unit-free measures. For relative measures, no units cannot be expressed. Okay. Relative measures are used to compare two or more series. For comparing, always we use relative measures only. No absolute measure is used for comparison purpose. But comparing to absolute and relative measures for computation process, absolute measures are more easy compared to relative measures. Now, first one is range. How to calculate range? For a given set of observation, range is nothing but difference between maximum and minimum value. That is, range is L minus S, larger value minus smaller value. Absolute range is L minus S. Coming to relative range, coefficient of range, L minus S by L plus S into 100. Okay. Sometimes he may give into 100 and sometimes he may not give, Nana. According to the answer, you have to proceed. If it is given in percentages, into 100 will be there. If it is in decimals, neglect that into 100. Okay. So relative range is equal to L minus S by L plus S into 100. That means relative range is absolute range by sum of extremes. L plus S means sum of extremes. So range is not based on all values. It is based only on two values. Range is not affected by origin, but it is affected by scale. All measures of dispersion, absolute measures of dispersion, are not affected by origin. They are affected only by scale. Okay. That means if y equal to a plus bx, neglect the origin a, we are considering only scale, mod b into range of x. Any measure of dispersion will not be negative. Okay. So mod b into range of x. If all observations are equal to k, range will become 0. Okay. Next, MD. Range is useful mostly in quality control, Nana. Please remember that point. Okay. It is mostly affected by extreme values also. Coming to mean deviation, we are considering absolute deviations here. That means we are considering the deviations by neglecting the negative signs. Okay. MD formula is summation mod x minus a by n for individual series, where a is mean or median or mode. MD about mean, median, or mode you can consider. If it is frequencies, summation f into mod x minus a by cat n. Okay. So if mean deviation is calculated with help of mean, then it is known as mean deviation about mean. If it is median, mean deviation about median, like that. Coefficient of MD, MD by A or MD by A into 100 according to the given answer, percentage or decimal. Okay. A means mean or median or median. Suppose coefficient of MD, MD about mean by mean, or MD about median by median, MD about mode by mode. According to the calculated average, our denominator will become mean or median or mode. Okay. What are the main points in MD? Very important point is mean deviation is minimum if it is taken about median. Okay. Sum of absolute deviation is minimum about median. Here we are considering absolute deviations only. That means MD about median is minimum. Again, coming to origin and scale effect, MD is also affected only by scale and it will not take negative values. So MD of y will be mod b into MD of x. It is based on all values. If all observations are equal to k, that means all are constants, MD will become 0. It is not used for further mathematical treatment. Combined MD is not there. Next one is quartile deviation. Quartile deviation is the measure of dispersion based on upper quartile and lower quartile. Interquartile range is given as Q3 minus Q1. And in that half, semi-interquartile range is nothing but QD, Q3 minus Q1 by 2. Semi-interquartile range. Interquartile range Q3 minus Q1. Semi-interquartile range or QD is Q3 minus Q1 by 2. Coefficient of QD, Q3 minus Q1 by Q3 plus Q1 into 100. If it is a symmetric distribution, it becomes QD by median into 100. So quartile deviation is the best measure for open-ended data. In central tendency, for open-ended data, best measure is median. Coming to dispersion, best measure for open-end is quartile deviation. It is a measure of dispersion that range in the sense that involves only 50% of the middle values. Okay, Q3 and Q1 involves only middle 50% of the values. It is not affected by extreme values. It is clear. Okay, 50% of the values means extreme values effect will not be there for QD, and it is best measure for open and none, very important. It is not capable for further algebraic treatment. It is susceptible to sampling fluctuations. This measure does not take into account the individual values occurring between Q1 and Q2. It is means that no idea about the variation of even 50% mid values is available from these measures. Okay. Always Q3 minus Q1 by 2, that is quartile deviation, and it is also affected only by scale and it not take negative. So QD of Y will be mod B into QD of X. Next one important one is standard deviation, which is the ideal measure of dispersion, and it is denoted by sigma. Sum of squares of the deviations is considered here. Sum of squares of the deviations from mean only considered. That means by sum of squares of the deviations from arithmetic mean is minimum. So SD is calculated only by mean. Almost all the properties satisfied by mean will be satisfied by SD. So SD formula already you know that. I have just given here. Please go through that one. Okay. The best relative measure for standard deviation is CV. Coefficient of SD is also there, sigma by x bar, but mostly we will use CV, coefficient of variation, SD by mean into 100. Mostly used relative measure is always CV, sigma by x bar into 100. Okay, that is CV, sigma by x bar into 100. Next, the data for which CV is less is said to be more consistent. Suppose we have 2 or more series. Compute CV for all the series. The series which we have less CV is said to be more consistent, more stable, more uniform, and less variable. Nana here, less variable means standard deviation will be less if all the values are nearer to mean. Okay, if all the values are nearer to mean, deviations will be less. CV will be less. Less variation means more consistent. Okay, more variation means less consistent. So CV less means more consistent, less variability. CV more means less consistent, more variability. Okay, this is very important point. Similarly, the square of SD is known as variance. Okay, variance is nothing but sum of squares of the deviations taken from mean by n. That means average of sum of squares of the deviations is nothing but variance. Average of sum of squares of deviations is variance. So sum of squares of the values can be computed by using the formula summation x square equal to n into sigma square plus x bar square. So variance for grouped data formula is summation fx square by n minus summation fx by n whole square. For SD, it will have root. For variance, there will be no root. So what is the relation between SD and variance? SD equal to root of variance, whereas variance equal to SD whole square. Properties. It is based on all values. Nana, SD is based on all values. It is used for further mathematical treatment. SD is not affected by change of origin, but it is affected by scale, even though it will not take negative. So again, if y equal to a plus bx is the relation, a is origin and b is scale, then SD of y can be computed by taking mod b into SD of x. But coming to variance, always square should be square. That means, very important point, variance of y is b square into variance of x. Scale should be square. Why? Because always variance is square of the SD. That means b should also be squared. So variance of y is b square variance of x. Combined SD is there, the formula. Okay. Square root of n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square by n1 plus n2. Combined SD. Further mathematical properties possible for SD. If all observations are equal, then variance and SD. Here, all the measure of dispersions, all absolute measure of dispersion rather than relative measures of dispersion. If all values are constant, all will become zero. All will become zero. If a company profits or remain constant for last 10 years, SD and variance will be zero, CV will be zero, like that. Okay. SD of first 10 natural numbers root n square minus 1 by 12 and variance is n square minus 1 by 12. For any two numbers, SD can be computed by taking half of the range. That means range is 2 times SD for two values. SD is considered as best measure or ideal measure of the dispersion. SD and variance will not be negative. Not only SD and variance, range, QD, MD, SD also will not be negative, Nana, but SD and variance are important. If all values are equal, SD and variance will become zero. Again, important points to remember in dispersion. Ideal measure of dispersion is always SD. Ideal measure of central tendency mean. Ideal measure of dispersion SD. If the data is in centimeters, then units of absolute measures all are in centimeters, but coming to variance, it is square. Units will become centimeter square. If it is kgs, the units, for variance it become kg square. For SD, it is kg only. Okay, for all other absolute measures, units are as it is, but for coming to variance, square of the units. Okay, the square root of variance is SD and square of SD is variance. This is the relation. SD is the only measure of dispersion used for further mathematical combined SD. Okay, further mathematical. MD and SD are based on all values. QD is the best measure for open-end, very important. For open-end data, which is the best measure? QD. Range is mostly affected by extreme values, whereas QD is not affected by extreme values. Extreme values effect is more for range and also for SD, but more range is mostly affected by extreme values, Nana. But for QD, it is not affected by extreme. Range is the easiest one to calculate compared to all measures. Simple and easy is range. If each observation is multiplied by a constant, SD is also multiplied by C. Coming to variance, it is multiplied by C square. Similarly, if each observation is divided by C, SD is divided by C and variance is divided by C square. Increase or decrease means no effect. Origin effect is not there, only scale effect. Okay. If any observation is added or subtracted, then SD and variance will not be changed. Origin effect is not there, only scale effect. But coming to variance, scale should be squared. If any, okay, empirical relation, 6QD equal to 5MD equal to 4SD. Okay, moderately symmetric or symmetric, the relation is 6QD, 5MD, 4SD. And QD is 2 by 3 SD, or relation between QD and MD is QD is 5 by 6 MD, MD is 4 by 5 SD. SD ensures highest degree of reliability. When all values are nearer to mean, SD will be less. When all values are farther to mean, SD will be high. Okay, deviation will be less when all values are nearer to mean. So SD ensures highest degree of reliability, QD ensures lowest degree. Okay, since it is taking only 50%. Low value of SD represent more uniformity. That means all values are nearer to mean. High values of SD means less uniformity. CV will not be changed if any observation is multiplied. Coming to relative measures, they are not affected by scale. They are affected only by origin. If each value is increased by K, CV will be decreased by K. If each value is decreased by CV is increased by K. But coming to multiplication and division, CV will never change. So CV is not affected by scale. It is affected by origin, but in inverse relation. That means if each value is increased, CV will decrease. If each value is decreased, CV will increase. This is about measures of dispersion. Coming to this table, Nana, very important table, Nana. Actually, this table, you can cover entire central tendency and dispersion in one view. Okay, just we will discuss this one. We have some ideal measures of central tendency properties and dispersion properties. First one is simple and easy to calculate. Coming to AM, GM and HM, Nana. AM is more easy, median is easy, mode is easy. Central tendencies I am discussing. So simple and easy to calculate are AM, median and mode, but GM and HM are not so simple. Rigidly defined. Already I have told mode is not rigidly defined. Only the measure which is not rigidly defined is mode. Okay. So all are rigidly defined except mode. Based on all values. AM, GM, HM are based on all values, but median and mode are not based on all values. Extreme values effect is greater for AM and least for HM, not affected by median. Okay. Similarly, mode also least effect. Sampling fluctuation effect is least for AM and greater for HM. Okay. Sampling stability. Sampling fluctuations least means stability will be more for AM. Similarly, sampling stability is greater means sampling stability is least for median and also HM and also mode. Okay, please remember these properties. Further mathematical treatment means combined property. It is for AM, GM and HM. Found by graph means only median and mode can be found by graph. Quasi curve is for median and histogram is for mode. Okay. And next, coming to dispersion. Simple and easy to calculate is range. Range is very simple and easy to calculate. Okay. And similarly, QD is also simple. MD is also moderate. But SD is not so simple. SD and variance are not so simple to calculate. Rigidly defined. All are rigidly defined. Only mode is not rigidly defined. All other measures of dispersion or central tendency is rigidly defined. Based on all values. Range is not based on all values. It is based on two values. QD is based on only 50%. That means range and QD are not based on all values, but MD, SD and variance based on all values. Extreme values effect will be high for range. Extreme values effect. Range itself depends on extreme values, L minus S, maximum and minimum. So high effect is by range. Extreme values effect is high for range, not affected. QD is not affected by extreme values. MD is moderately affected. Again, greater effect. Greater and high Nana. Here, coming to range and SD, range is mostly affected by extreme values. SD also greater effect. If in the options range is given, go for range. If it is not range, SD is greater affected by extreme values, even though variance is also greater. Sampling fluctuation effect. Okay. Least effect for AM, similarly least effect for SD also. Okay. SD and variance are least affected by sampling fluctuations. Stability is more for AM, that means for SD also stability will be more. Okay. Further mathematical treatment, combined property is only for SD, combined SD. Similarly, combined variance is also there. Found by graph. Only measure of dispersion found by graph is only QD. Quartiles can be calculated by Ozai curve. So you can calculate QD by using Ozai curve. Coming to open-ended data, Nana, best measure of central tendency is median and best measure of dispersion is QD. Very important point. If it is the data is given in individual series, you can calculate AM, GM and HM without converting to exclusive. But coming to median, mode, range, QD, you have to convert. Okay, for SD also it is no need to convert inclusive to exclusive. Mid value series is given means you can calculate AM, GM, HM directly. That means already mid values are given. Like even though MD and SD can also be computed, but median, mode, range and QD cannot be computed for mid value series. You have to convert mid value series into exclusive series. Okay, origin effect. Origin effect is there for central tendencies, but no for absolute measures. Relative measures are affected by origin, but absolute measures are not affected. So, origin effect dependent on change of origin. All measures of central tendencies are dependent on change of origin. That means origin change is not possible. Since the values are going to be changed, origin change is not possible for central tendencies. Similarly, coming to dispersions, origin effect is independent, Nana. That means origin change is possible. So dispersion, all absolute measures are not affected by origin. Scale effect, all central tendencies and all absolute measures are affected by scale. So change of scale is not possible for all MCT and absolute measures. Coming to relative measures of dispersion, they are not affected by scale. They are affected only by origin. Okay. So please remember these points. This is about central tendency and dispersion. Next, I am going to continue about sampling. So before sampling, there are some basic definitions. Population. Population or universe. What is meant by population? In statistics, population means the whole information which we are going to study. Suppose we are going to study the class students. The class students is considered as population. Or if you are studying the whole college, college is known as population like that. So population in statistics means the whole of the information which comes under the purview of the statistical investigation. Okay, which we are going to investigate, that whole part is population. It is the totality of all the observations of the statistical experiment or inquiry. A population may be finite or infinite. Sometimes it is countable or sometimes it is not countable like that. Okay, the population of weights of students of class 11, class 12 in a government school is an example of finite population. The population of pressure at different points in the atmosphere is an example of infinite population. So types of population. First one is finite. If it is countable and the items in the population are fixed and limited, it is known as finite. So example, best example is number of students in the class or number of workers in a factory like that. Infinite population. If a population consists of infinite number of items, it is an infinite. Stars in the sky, okay, mosquitoes in Kolkata like that, which we cannot be counted. That is known as infinite population. Okay. Population of all real numbers lying between 5 and 20. There are many values between 5 and 20, infinite. So it is also infinite population. So real population. A population consisting of the items which are physically present is known as real population. Physically present means they are visible to us and we are studying those. That is known as real population or existent population. Hypothetical or imaginary population means the population consists of the results of the repeated trials. It is known as hypothetical population. Just we are imagining, but we are not performing the experiment. In probability, we are just imagining that we are repeating the trials. That is nothing but hypothetical or imaginary. Tossing of a coin or rolling of a die. All these are imaginary populations or hypothetical populations. So that is about population. Next, sample. Population is a large quantity. Okay. If we are not able to study the whole quantity, then we will draw a small part from that. That is known as sample. A part of the population selected for study is called as sample. In other words, selection of group of individuals or item from a population in such a way that this group represents the population is known as sample. Sample is always finite, okay. Sampling is the process of drawing sample from the population. So that process is known as sampling. If you are drawing a sample from population, that is known as sampling, okay. So sample is the part of the population selected on some basis of a finite subset of the population. Sample units means the units forming the samples are called sample units. Suppose I am drawing 5, 5, 5, 5 like that. Each 5, okay, first if I have drawn first 5 samples, that is first unit. Another 10 samples, that is second unit. Each member is known as units, okay. Group of members is known as units. Sampling frame, very important. A list of all possible members in the population, okay, and which we are going to make the sample from that population. A complete list of sampling units is known as sample frame. Sample frame means a complete list of sampling units. Sample fraction. Here population size is denoted by capital N and sample size is denoted by small n. If the sample size is greater than or equal to 30, it is considered as large sample. If it is less than 30, it is small sample. So sample size is small n, capital N is population. Suppose there are 100 values in total, capital N is 100. I am drawing only 20 from them, small n is 20. So n by n, that means sample size by population size is called as sampling fraction, where n is sample size and capital N is population size. Next important definition is census and survey. Census means studying the whole population, okay. If you are studying the whole information of all the population units, it is known as complete enumeration or census. Studying about the population is census. If you are not able to study the whole population, then you opt for survey. That means sample study of only sample values, okay. Study of the sample is known as survey, okay. Survey means part enumeration and census means complete enumeration. Complete means we are studying the whole population. Census. Sample means we are studying the only part of the population, part enumeration, okay. Parameter and statistics. The statistical constants computed for all the population values are known as parameters. For whole population, you have computed population mean, population variance, population SD, population proportion. These are all known as parameters. If you are computing statistical constants for sample only, those are considered as statistics. Sample mean, sample variance, sample SD, sample proportion. Okay, these are statistics. Okay, here I'm giving one better example. Notations, very important, okay. Population mean is denoted by mu, whereas sample mean is denoted by x bar. Population SD is denoted by sigma, whereas sample SD is denoted by s. Similarly, population variance sigma square, sample variance s square. Population proportion is capital P, sample proportion is small p. Similarly, population size capital N means sample size is small n, okay. Statistics is computed from sample, parameter is computed for population. So sometimes he will give the denotations. Which of the following is population mean? Which of the following is sample mean? Please aware of the denotations, okay? Notations, okay? Next, sampling distribution. Suppose you are drawing different samples from your population. Capital N is the population size, and from that I am drawing different samples. So each sample can be computed again a statistic. Suppose from 100 values, first of all I have drawn 5 values. For those 5 values I can calculate mean. Another 5 values I have drawn, again I have calculated mean, like that. So for each sample I can compute the statistic. So these statistics tabulated together is known as sampling distribution. Sampling distribution is nothing but probability distribution of the statistic. Suppose after drawing the samples, I have got the sample means for 3 out of 10 samples, sample mean is 3 for 3 samples. Then what is the probability? 3 by 10. Next, for example, I have got sample mean 4 for 2 samples, 2 by 10, like that. For each statistic, if I am computing probability distribution, that is known as sampling distribution. It is a frequency distribution which is formed with various values of statistics. Frequency means probability, okay, computed for different samples. If the sample size is greater than sampling distribution, then automatically every distribution will go to symmetric normal. Anyway, sampling distribution is nothing but probability distribution of statistic is known as sampling distribution. Next, very important definition is standard error. For this sampling distribution, again, if I have computed standard deviation, that means the standard deviation of the sampling distribution is known as standard error. The standard deviation of sampling distribution. Standard deviation is nothing but standard error, but here sampling distribution, we are computing standard deviation for sampling distribution. It is known as standard error. It is simply denoted by SE. Some of the formulas, Nana. These are the formulas in sampling. Okay, sample mean. Here samples may drawn with replacement and also without replacement. With replacement means total number of samples are n power n, capital N power small n. Without replacement means we can draw total number of samples NCN. Okay, please refer the formulas. Okay, similarly, sample mean standard error is sigma by root n if the sampling is done with replacement. If it is done without replacement, always we have to multiply FPC root n minus n by n minus 1. Without replacement means standard error formula is this one. If sigma is known, that means population SD is given, use these formulas. If population SD is not known, you have to estimate population SD from sample SD, where the formula is S equal to square root of summation xi minus x bar whole square by n. Okay, whole square by n. Standard deviation formula. After computing SD, then our formula, standard error formula will be with replacement means S by root n minus 1, where S is sample SD, and without replacement, always multiply with FPC. Root n minus n by n minus 1 into S by root n minus 1. Okay, this is about sample mean. If it is sample proportion, root PQ by n, and sampling is done with replacement. Root n minus n by n minus 1 into root PQ by n when sampling is done without replacement. Here n root n minus n by n minus 1 is known as finite population correction. If the sample size is less than 5% of the population, FBC will become 1 only. Okay. If that means sample fraction n by n is less than 0.05, no FPC is required. If it is greater than 0.05 only, we have to multiply FPC. Anyway, FPC is multiplied in the case of without replacement. As sample size increases, standard error decreases. One of the important points. Sample size increases, standard error decreases. Since standard error is sigma by root n, it is always inversely proportional to the root of sample size. So if sample size increases, standard error decreases. If sample size decreases, standard error increases. Standard error is inversely proportional to square root of the sample size of size n. Very important point. So reciprocal of standard error is known as precision. So that means precision is directly proportional. Standard error is inversely proportional to the square root of sample size n. That means precision is the inverse. Precision is the reciprocal of standard error. So it is directly proportional to square root of sample size. So what are the basic principles in sample survey? There are 4 principles. Law of statistical regularity, which states that reasonably a larger number of items selected at random from a large group of items will on average represent the characteristics of the group. Will on average. That means principle of statistical regularity. Large sample will on average possess the characteristics of the population. Average term means it is the law of statistical regularity. Law of inertia of large numbers. It is also saying that simply it is law of inertia, Nana. Law of inertia. Okay. So if the sample size is large, then you can get more reliable and accurate results. This principle is known as law of inertia. Sample size is large, you can get more reliable and accurate results, consistent results. Principle of optimization. The principle of optimization ensures that optimum level of efficiency can be done with minimum cost. Minimum cost, maximum efficiency. Okay, that principle is known as optimization. Principle of validity states that our sample design should be such that we can draw valid conclusions and valid tests of hypothesis. Valid means principle of validity. So average ane term kanipiste law of statistical regularity. Large numbers principle em cheptoni, large sample kanaka draw cheste consistent and accurate and reliable results vastayani cheptoni. Optimization ante enti? Maximum optimization. Optimization means maximum efficiency with minimum cost. Okay, validity ante valid conclusions untayi. Okay, next, sampling errors and non-sampling errors. What is meant by sampling error? మన పాపులేషన్ నుంచి శాంపుల్ డ్రా చేస్తున్నాం మనం. ఎప్పుడు కూడా శాంపుల్ రిజల్ట్స్ నుంచి పాపులేషన్ ఎస్టిమేట్ చేసేప్పుడు ఆల్వేస్ ఇట్ మే బి ట్రూ ఆర్ మే నాట్ బి ట్రూ. సమ్ ఎర్రర్స్ రావచ్చు. ఆ ఎర్రర్ నే శాంప్లింగ్ ఎర్రర్ అంటాం. అంటే డిఫరెన్స్ బిట్వీన్ రిజల్ట్స్ అబ్టైన్ ఫ్రమ్ శాంపుల్ అండ్ ద ట్రూ పాపులేషన్ వాల్యూ. అంటే పారామీటర్ వాల్యూకి, పారామీటర్ అంటే పాపులేషన్ సంబంధించిన మీన్, మీరు శాంపుల్ మీన్ కనుక్కున్నారు స్టాటిస్టిక్, ఆ రెండు డిఫరెన్స్ ఉన్నాయండి, దాన్నే మనం శాంప్లింగ్ ఎర్రర్ అంటాము. అంటే శాంపుల్ ద్వారా పాపులేషన్ ఎస్టిమేట్ చేసేప్పుడు ఆల్వేస్ ట్రూ రిజల్ట్స్ రావాలని లేదు, ఎర్రర్ రావచ్చు. ఆ డిఫరెన్స్ నే ఎర్రర్ అంటాం. డిఫరెన్స్ బిట్వీన్ పారామీటర్ అండ్ స్టాటిస్టిక్ ఈస్ sampling error. Sampling error have their origin in sampling and arise due to fact that only a part of the population has been used. పాపులేషన్ మొత్తం స్టడీ చేయకుండా శాంపుల్ మాత్రమే స్టడీ చేస్తున్నాం, దాన్నే పాపులేషన్ కి అప్లై చేస్తున్నాం. దీని వల్లే వచ్చే ఎర్రర్ అండి శాంప్లింగ్ ఎర్రర్. ఓకే, కొన్నిసార్లు మనం ఎస్టిమేట్ చేసింది ట్రూ అవ్వచ్చు, కొన్నిసార్లు అవ్వకపోవచ్చు. ఆ డిఫరెన్స్ ఏదైతే ఉందో పారామీటర్ కి స్టాటిస్టిక్ కి, దాన్నే శాంప్లింగ్ ఎర్రర్ అంటున్నాం. ఈ శాంప్లింగ్ ఎర్రర్ అనేది మనకి సెన్సస్ ఎన్యూమరేషన్ లో రాదు. సెన్సస్ అంటే పాపులేషన్ మొత్తాన్ని స్టడీ చేసేదాన్ని సెన్సస్ అంటాం. అక్కడ శాంప్లింగ్ ఎర్రర్ రాదు. శాంప్లింగ్ ఎర్రర్ అంటే ఏంటండి, శాంపుల్ ద్వారా పాపులేషన్ ఎస్టిమేట్ చేస్తున్నాం. ఎందులో చేస్తాం, సర్వేలో చేస్తాం. ఓకే, సో ఓన్లీ శాంప్లింగ్ ఎర్రర్స్ విల్ అక్కర్ ఓన్లీ ఇన్ సర్వే బట్ నాట్ ఇన్ కంప్లీట్ ఎన్యూమరేషన్. శాంప్లింగ్ ఎర్రర్స్ ఎక్కడ వస్తాయి అంటే సర్వే, శాంపుల్ సర్వేలోనే వస్తాయి, కంప్లీట్ ఎన్యూమరేషన్ లో రావు. దిస్ ఇస్ ద ఇంపార్టెంట్ పాయింట్. మరి నాన్ శాంప్లింగ్ ఎర్రర్స్ అంటే ఏంటి, జనరల్ గా మనం ఎప్పుడైనా ఇంటర్వ్యూ చేసేప్పుడు, అది సెన్సస్ కావచ్చు, సర్వే కావచ్చు, ఇంటర్వ్యూ చేసేప్పుడు మన తప్పిదాల వల్ల, లేదా రెస్పాండెంట్ ఎన్యూమరేటర్ ఉంటాడు, రెస్పాండెంట్ ఉంటాడు, క్వశ్చనీర్ ఉంటుంది, తర్వాత మనం డేటా కలెక్ట్ చేశాక స్క్రూటినీ చేస్తాం, ఆర్గనైజ్ చేస్తాం, క్లాసిఫికేషన్, ప్రెజెంటేషన్, వీటిలన్నిట్లో జరిగే ఎర్రర్స్ అండి నాన్ శాంప్లింగ్ ఎర్రర్స్. అంటే నాన్ శాంప్లింగ్ ఎర్రర్స్ అనేవి అటు సెన్సస్ లో రావచ్చు, ఇటు సర్వేలో, అంటే పాపులేషన్ స్టడీలో కూడా రావచ్చు, శాంపుల్ స్టడీలో కూడా రావచ్చు. వెరీ ఇంపార్టెంట్. శాంప్లింగ్ ఎర్రర్స్ ఎక్కడ వస్తాయి, ఓన్లీ ఇన్ సర్వే, శాంపుల్ ని స్టడీ చేసేప్పుడు మాత్రమే వస్తాయి. శాంప్లింగ్ ఎర్రర్స్ ఆర్ అక్కర్డ్ ఓన్లీ ఇన్ సర్వే, వేరాజ్ నాన్ శాంప్లింగ్ ఎర్రర్స్ మే అక్కర్ బోత్ ఇన్ సెన్సస్ అండ్ ఆల్సో ఇన్ సర్వే. కంప్లీట్ ఎన్యూమరేషన్, పార్ట్ ఎన్యూమరేషన్ రెండిట్లో నాన్ శాంప్లింగ్ ఎర్రర్స్ ఉంటాయి. సో నాన్ శాంప్లింగ్ ఎర్రర్స్ అంటే ఏంటి, మనం ఇన్వెస్టిగేషన్ చేసేప్పుడు చేసే తప్పిదాలు. ఓకే, sampling error is the important point. Sampling error is totally absent in complete enumeration or census, but non-sampling errors are present in both complete enumeration and sample survey. Very important point. Next types of sampling. There are three types of sampling: probability sampling, that means random sampling, non-probability sampling, and mixed sampling. Coming to random sampling or probability sampling, there are again three methods. Okay, first one is simple random sampling. And a simple random sampling means we are drawing a sample from whole population. Simply we are drawing sample in random manner from whole population. That is known as simple random sampling. It is method of selecting a sample in such a way that each and every unit of population has equal chance of being selected. In this one, we are drawing a sample from whole population means we can draw any unit. Each unit has equal chance of being selected. That case is simple random sampling. In this, we have two cases: simple random sampling with replacement and without replacement. Okay, simple random sampling with replacement means we are, one unit is drawn and again it is replaced and another unit is drawn, like that. That is known as with replacement. Without replacement means one unit is drawn and it is thrown away, and another, from remaining units we are drawing another unit, again it is thrown away, and remaining units we are drawing, like that, without replacement. In simple random sampling with replacement, probability is always 1 by n. That means selecting each unit in any draw is always equal to 1 by n, since all the units will be there only. Coming to without replacement, probability of selecting each unit will be changed 1 by n minus r plus 1, where r is rth draw. Suppose in first draw, our sample of selecting first unit is 1 by n. In second draw, probability is 1 by n minus 1. In third draw, 1 by n minus 2, so on. Since for each draw, one unit is reduced, like that. Okay, so coming to this point, sometimes you may ask, in both cases, which is the best one? Means always simple random sampling with replacement and without replacement. Without replacement is the best one. Variance of simple random sampling without replacement is always less than with replacement. So variance less means consistency is for without replacement compared to with replacement. SRS, simple random sampling, can be done in two ways: lottery method and random numbers method. Lottery method means simply taking all the slips, suppose there are n members, writing all the names and drawing lottery from that is lottery method. And then second one, random number method. We have some random numbers, selecting some numbers from those random number table is the second method. This is the best method of doing simple random sampling. Okay, so here I am giving the formula. Total number of sample in case of with replacement are n power n, and without replacement are NCN. Very important. Okay, so simple random sampling is completely free from sampler's bias. Since each unit has equal chance of being selected, there is no bias. Okay, ఇదే యూనిట్ తీసుకోవాలని ఎక్కడా లేదు. బయాస్ అంటే పక్షపాతం అనేది లేదు. Okay, and it is a reliable sampling method. Out of all methods, reliable is simple random sampling. It is used when it is used when population size is not so large and there is not much heterogeneity. అంటే మనకున్న పాపులేషన్ యూనిట్స్ అన్ని మాక్సిమం హోమోజీనియస్ అయి ఉండాలి, హెట్రోజీనియస్ ఎక్కువ ఉండకూడదు. అలాంటి కేసులో సింపుల్ ర్యాండమ్ శాంప్లింగ్ యూజ్ చేయొచ్చు. నెక్స్ట్ స్ట్రాటిఫైడ్ శాంప్లింగ్ అండ్ మల్టీ స్టేజ్ శాంప్లింగ్, ఈ రెండు కూడా మనకి probability sampling కింద వస్తాయి. Stratified sampling. In stratified sampling, population is divided into different stratas. Coming to simple random sampling లో ఏం చెప్పుకున్నాం, హెట్రోజినిటీ ఎక్కువ ఉండదు అన్నాం. బట్ ఇక్కడ హెట్రోజినిటీ ఎక్కువ ఉంటుంది. హెట్రోజినిటీ ఎక్కువ ఉన్నప్పుడు మనం ఏం చేయాల్సి వస్తుంది, బేస్డ్ ఆన్ హోమోజీనియస్ వాటిని డిఫరెంట్ గ్రూప్స్ గా డివైడ్ చేస్తున్నాం. ఆ గ్రూప్స్ నే స్ట్రాటా అంటాం. అంటే పాపులేషన్ మొత్తాన్ని ముందు డిఫరెంట్ స్ట్రాటాగా డివైడ్ చేస్తున్నాం. ప్రతి స్ట్రాటా నుంచి మళ్ళీ శాంపుల్ ని ర్యాండమ్ గా డ్రా చేస్తున్నాం. సింపుల్ ర్యాండమ్ శాంప్లింగ్ లో మొత్తం పాపులేషన్ నుంచి ర్యాండమ్ గా శాంపుల్ డ్రా చేస్తున్నాం. బట్ ఇక్కడ ముందు పాపులేషన్ ని డిఫరెంట్ స్ట్రాటాస్ గ్రూప్స్ గా డివైడ్ చేసి ప్రతి గ్రూప్ నుంచి శాంపుల్ డ్రా చేస్తున్నాం. స్ట్రాటిఫైడ్ ర్యాండమ్ శాంప్లింగ్. దీనిలో మళ్ళీ 2 మెథడ్స్ నాన్న, ప్రపోర్షనల్ అలొకేషన్, ఆప్టిమల్. మరి ప్రతి స్ట్రాటా నుంచి శాంపుల్ సైజ్ ఎంత తీయాలి అంటే బౌలీ ఏం చెప్తున్నారంటే, ప్రపోర్షనల్ అలొకేషన్ బౌలీ చెప్పాడు, శాంపుల్ సైజ్ షుడ్ బి ప్రపోర్షనల్ టు పాపులేషన్ సైజ్. అంటే ఎన్ఐ అంటే ఇక్కడ ప్రతి స్ట్రాటా నుంచి డ్రా చేయాల్సిన శాంపుల్ సైజ్. క్యాపిటల్ ఎన్ఐ అంటే స్ట్రాటమ్ సైజ్. ఫర్ ఎగ్జాంపుల్ 100 మెంబర్స్ ఉన్న పాపులేషన్ లో నేను ఫస్ట్ గ్రూప్ లో ఒక 20 మెంబర్స్ ఉన్నారు, N1 20 అవుతుంది. ఆ N1 20 నుంచి నేను ఒక 10 మెంబర్స్ డ్రా చేస్తున్నాను అనుకోండి, స్మాల్ n1 10 అవుతుంది. అది ఓకే. ప్రపోర్షనల్ అలొకేషన్ లో శాంపుల్ సైజ్ షుడ్ బి ప్రపోర్షనల్ టు పాపులేషన్ సైజ్. కమింగ్ టు ఆప్టిమల్ అలొకేషన్, మనకి మచ్ వేరియబిలిటీ ఉందనుకోండి, హెట్రోజినిటీ ఎక్కువగా ఉంది ప్రతి స్ట్రాటమ్ మధ్య, బిట్వీన్ స్ట్రాటా కూడా హెట్రోజినిటీ ఎక్కువ ఉంది. అప్పుడు వేరియబిలిటీ స్టాండర్డ్ డీవియేషన్ ని మినిమైజ్ చేయాలి, వేరియబిలిటీ మినిమైజ్ చేయాలి. దానికోసమే ఆప్టిమల్ అలొకేషన్ అన్నా నీమాన్ అలొకేషన్ అన్నా ఒకటే, నీమాన్ ఆప్టిమల్ అలొకేషన్. శాంపుల్ సైజ్ షుడ్ బి ప్రపోర్షనల్ టు బోత్ పాపులేషన్ సైజ్ అండ్ ఆల్సో ఎస్డి. సో ప్రపోర్షనల్ అలొకేషన్ లో శాంపుల్ సైజ్ ఈస్ ప్రపోర్షనల్ టు పాపులేషన్ సైజ్ అని చెప్పాలి. ఆప్టిమల్ అలొకేషన్ అంటే శాంపుల్ సైజ్ ఈస్ ప్రపోర్షనల్ టు బోత్ పాపులేషన్ సైజ్ అండ్ ఆల్సో ఎస్డి. ఓకే, మరి ఆప్టిమల్ అలొకేషన్ ఎప్పుడు వాడాలండి, when population size is too large and also too heterogeneous. It reduces variability and also minimizes the cost. This is about stratified random sampling. Multi-stage sampling, ఇది కూడా ప్రాబబిలిటీ శాంప్లింగ్. మల్టీ స్టేజ్ శాంప్లింగ్ అంటే ఏంటి, మనకి రిక్వైర్డ్ శాంపుల్ స్టేజ్ ని డిఫరెంట్ స్టేజెస్ లో అప్టైన్ చేస్తాం. Okay, in this method sample of elementary units is selected at different stages. Firstly we select sample and from among them another sample is drawn like that. More flexible compared to other methods. Flexible sampling design ఏది అని అడుగుతారు, మల్టీ స్టేజ్ శాంప్లింగ్. ఓకేనా, ఫ్లెక్సిబుల్ ఏది అంటే మల్టీ స్టేజ్ శాంప్లింగ్. బట్ కంపేర్ టు స్ట్రాటిఫైడ్ శాంప్లింగ్ ఇట్ ఈస్ లెస్ యాక్యురేట్. బట్ అన్నిటికన్నా రిలయబుల్ ఏదండి, సింపుల్ ర్యాండమ్ శాంప్లింగ్. సెకండ్ ప్రిఫరెన్స్ మనం స్ట్రాటిఫైడ్ కి ఇవ్వచ్చు. మల్టీ స్టేజ్ అనేది అంత బెస్ట్ మెథడ్ కాదు, బట్ ఫ్లెక్సిబుల్ శాంప్లింగ్ డిజైన్. ఎందుకంటే సపోజ్ మనం ఇండియా నుంచి కొన్ని స్టేట్స్ ని సెలెక్ట్ చేస్తాం, అందులో మళ్ళీ స్టేట్స్ నుంచి డిఫరెంట్ డిస్ట్రిక్ట్ సెలెక్ట్ చేస్తాం, మళ్ళీ మండల్స్, అందులో విలేజెస్, తాలూకాస్ ఇలా తీసుకుంటూ వెళ్తాం. ఇట్లాగానే మల్టీ స్టేజ్ శాంప్లింగ్. ఓకే, ఈ 3 కూడా ప్రాబబిలిటీ శాంప్లింగ్. మరి నాన్ ప్రాబబిలిటీ శాంప్లింగ్ అంటే ఏంటి, ప్రతి యూనిట్ కి ఈక్వల్ ఛాన్స్ ఆఫ్ బీయింగ్ సెలక్షన్ ఉండదు. మన ఇష్టం, వాడి ఇష్టం వచ్చినట్టు శాంపుల్ డ్రా చేసుకుంటాడు, వాడికి ఏవి నచ్చాయో అవే తీసుకుంటాడు. అదే నాన్ ప్రాబబిలిటీ శాంప్లింగ్. దీనిలో పర్పసివ్ శాంప్లింగ్, జడ్జిమెంట్, ఆల్ డెలిబరేట్ అన్ని ఒకటేనా. పర్పసివ్ శాంప్లింగ్ అంటే ఏంటి, వాడి పర్పస్ ఏదో దాన్ని బట్టే శాంప్లింగ్ డ్రా చేస్తున్నాడు. శాంప్లింగ్ ఈస్ డ్రాన్ ఫ్రమ్ పాపులేషన్ బేస్డ్ ఆన్ ఎంటైర్ జడ్జిమెంట్ ఆఫ్ ద ఇన్వెస్టిగేటర్. ఇట్ ఈస్ ప్యూర్లీ బేస్డ్ ఆన్ డిస్క్రిషన్ ఆఫ్ ద శాంప్లర్. శాంప్లర్ కి ఇష్టానుసారంగా తీసుకునే శాంపుల్. ర్యాండమ్నెస్ ఫైండ్స్ నో ప్లేస్. ఇక్కడ ర్యాండమ్నెస్ అనేది ఉండదు. ర్యాండమ్ అంటే ఏంటి, దేనికైనా ఈక్వల్ ఛాన్స్ ఉంటుంది ర్యాండమ్నెస్. ఇక్కడ ర్యాండమ్నెస్ ఉండదు, వాడికి ఎవరు కావాలో వానే తీసుకుంటాడు. సో దీనివల్ల నో టెస్టింగ్ ఆఫ్ హైపోథసిస్ పాసిబుల్ విత్ టైప్ ఆఫ్ శాంప్లింగ్. ఎందుకంటే ర్యాండమ్నెస్ లేదు, అన్ని రిలయబుల్ అవుతాయో లేదో తెలియదు. ఓకే, ఇట్ ఈస్ వెరీ మోస్ట్ ఫ్లెక్సిబుల్ శాంప్లింగ్ డిజైన్. ఓకే, ఇది నాన్ ప్రాబబిలిటీ శాంప్లింగ్ ఆర్ జడ్జిమెంట్ ఆర్ పర్పసివ్. ఇక మిక్స్డ్ శాంప్లింగ్, థర్డ్ టైప్. ప్రాబబిలిటీ నాన్ ప్రాబబిలిటీ రెండు మిక్స్ అయ్యేది మిక్స్డ్ శాంప్లింగ్, సిస్టమాటిక్ శాంప్లింగ్ అండి. సిస్టమాటిక్ శాంప్లింగ్ అంటే ఏంటి? ఫస్ట్ మనం పాపులేషన్ మొత్తం నుంచి ఒక యూనిట్ ని ర్యాండమ్ గా తీసుకుంటాం, అక్కడ ప్రాబిలిటీ మిక్స్ చేస్తున్నాం. ఓకే, తర్వాత ఎవ్రీ కేత్ యూనిట్ తీసుకుంటాం, అంటే మన ఇష్ట ప్రకారం ఎవ్రీ కేత్. ఫస్ట్ మాత్రం ర్యాండమ్ తీస్తున్నాం, తర్వాత ఎవ్రీ కేత్ యూనిట్ అని ఒక సిస్టమ్ పెట్టుకుంటున్నాం. దట్ ఈస్ నోన్ యాజ్ సిస్టమాటిక్ శాంప్లింగ్. రెగ్యులర్ ఇంటర్వెల్స్ లో శాంపుల్ డ్రా చేసే ప్రాసెసే సిస్టమాటిక్ శాంప్లింగ్. దీనిలో మీరు గుర్తుంచుకోవాల్సింది ఈ పాయింట్. ఇఫ్ దేర్ ఆర్ n sampling units in the population which are arranged in systematic order serially, okay, some serial order లో ఉన్నాయి 1 to n, then we want to draw a sample size n. శాంపుల్ సైకిల్ ఎంత అంటే k ఈక్వల్ టు క్యాపిటల్ N బై స్మాల్ n. శాంప్లింగ్ ఇంటర్వెల్ అంటాం దీన్ని. దీని మీద ప్రాబ్లమ్స్ కూడా అడుగుతున్నారు. ఓకేనా, k ఈజ్ నోన్ యాజ్ శాంపుల్ ఇంటర్వెల్. పాపులేషన్ సైజ్ 50 ఉందండి, శాంపుల్ సైజ్ ఏమో 10. ఏ ఇంటర్వెల్ లో తీస్తావు? 50/10, ఎవ్రీ 50 యూనిట్ తీయాలి. ఓకే, లైక్ దట్. ఇఫ్ దెర్ ఈస్ అన్డిటెక్టెడ్ పీరియాడిసిటీ, కరెక్ట్ గా మనకి పీరియడ్ ఎంతో తెలియలేదు, శాంప్లింగ్ యూనిట్స్ అన్ని ఆర్డర్ లో లేవు, అప్పుడు దిస్ ఈస్ ద డేంజరస్ ప్లాన్. సిస్టమాటిక్ శాంప్లింగ్ కెనాట్ బి యూస్డ్. ఓకే, so these are the different types of sampling, Nana. After that, just I will briefly give all these sampling in some flow chart. Okay na, student sampling 3 methods unnai: probability sampling, which is known as random sampling, non probability sampling, and mixed sampling. Out of probability sampling, 4 types are there: simple random sampling, stratified random sampling, cluster sampling, multi stage sampling. Cluster sampling అంటే ఏంటంటే, ఇందాక మనం స్ట్రాటాస్ అన్నాం, గ్రూప్స్, ఇక్కడ వాటిని క్లస్టర్స్ అని కూడా అంటారు. స్ట్రాటిఫైడ్ ర్యాండమ్ శాంప్లింగ్ లో ప్రతి స్ట్రాటా నుంచి ర్యాండమ్ గా తీసుకుంటాం. కమింగ్ టు క్లస్టర్ అలా కాదు, ఒక క్లస్టర్ మొత్తాన్ని తీసేసుకుంటాం, ఒక గ్రూప్ మొత్తాన్ని తీసేసుకుంటాం. అట్లా కొన్ని క్లస్టర్స్ ని తీసుకునే దాన్ని క్లస్టర్ శాంప్లింగ్. ఈ 4 కూడా ప్రాబబిలిటీ శాంప్లింగ్స్. నాన్ ప్రాబబిలిటీ శాంప్లింగ్ కింద కన్వీనియన్స్ శాంప్లింగ్, వాడి కన్వీనియంట్ ప్రకారం తీసుకుంటాడు. పర్పసివ్ శాంప్లింగ్ అన్నాం. కోటా శాంప్లింగ్. కోటా శాంప్లింగ్ అంటే ప్రతి శాంపుల్ కి సర్టెన్ కోటా అరేంజ్ చేసుకుంటాం, ఆ కోటా ప్రకారం దీని నుంచి ఒక 5 తీయాలి, దాని నుంచి ఒక 10 తీయాలి, దీన్ని కోటా శాంప్లింగ్. ఇది కూడా నాన్ ప్రాబబిలిటీ. స్నోబాల్ శాంప్లింగ్. స్నోబాల్ శాంప్లింగ్ అంటే ఏంటి? ఫస్ట్ మీరు ఒక 3 మెంబర్స్ ని అపాయింట్ చేసుకుంటారు, ఆ 3 మెంబర్స్ ని ఇంకో 3 మెంబర్స్ ని అపాయింట్ చేసుకోమంటారు, ఆ 3 ఇంకో 3, ఇట్లా చేసేదాన్ని స్నోబాల్ శాంప్లింగ్ అంటారు. లాస్ట్ వన్ ఈస్ మిక్స్డ్ శాంప్లింగ్, సిస్టమాటిక్ శాంప్లింగ్. ఓకేనా అన్న, ఎందుకు ఇచ్చానంటే ఇక్కడ వాడు ఎగ్జాంపుల్స్ అడుగుతున్నాడు. విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈస్ ప్రాబబిలిటీ శాంప్లింగ్, విచ్ ఆఫ్ దీస్ నాన్ ప్రాబబిలిటీ, అందుకని చూసుకోండి. ఓకే, ఇక ఈ టేబుల్ ఒక్కసారి స్టడీ చేసుకోండి. ఎగ్జాంపుల్స్ ఇస్తున్నాడు మనకి, ఆ ఎగ్జాంపుల్ ఇచ్చేసి ఇదే మెథడ్ యూస్ చేస్తారా అని అంటున్నాడు. దానికోసం సింపుల్ ర్యాండమ్. సింపుల్ ర్యాండమ్ అంటే ఏంటి? సింపుల్ గా మనకి డెఫినిషన్, ఎవ్రీ ఎలిమెంట్ హ్యాస్ ఈక్వల్ ఛాన్స్ ఆఫ్ బీయింగ్ సెలెక్టెడ్ కదా. సో డ్రాయింగ్ 100 నేమ్స్ ఫ్రమ్ ఏ బౌల్ ఆఫ్ 1000 ఎంప్లాయీ ఐడీస్ అన్నాడు. సో సింపుల్ గా ఇలా మీకు ఏదైనా ఎగ్జాంపుల్ ఇచ్చాడు, యూ హ్యావ్ టు డ్రా some persons or some chalk pieces from a group of persons or group of chalk pieces, a product from group of products అన్నాడు. ఓకే, మీరు ఇక్కడ గుర్తుంచుకోవాల్సింది ఏంటి? పాపులేషన్ హెట్రోజీనియస్ గా లేదు, అటు ఎక్కువ లార్జ్ గా లేదు, అప్పుడు సింపుల్ ర్యాండమ్ శాంప్లింగ్ యూస్ చేసేయండి. సిస్టమాటిక్ శాంప్లింగ్ ఎప్పుడు యూస్ చేయాలి? సైకిల్ ప్రకారం ఇచ్చాడు. సెలెక్ట్ ఎవ్రీ కేత్ ఐటమ్ అన్నాడు, అది సిస్టమాటిక్ అవుతుంది. చూసింగ్ ఎవ్రీ 20th కస్టమర్ ఫ్రమ్ ఏ చెక్అవుట్ క్యూ, ఏ మెథడ్ అవుతుంది? సిస్టమాటిక్ శాంప్లింగ్. స్ట్రాటిఫైడ్ ర్యాండమ్ శాంప్లింగ్ ఎప్పుడు యూస్ చేయాలి? మనకి హెట్రోజినిటీ ఎక్కువ ఉందండి, పాపులేషన్ లార్జ్ గా ఉంది, హెట్రోజినిటీ ఎక్కువ ఉంది. అంటే ఫర్ ఎగ్జాంపుల్ ఎంప్లాయీస్, ఫ్యాక్టరీ ఎంప్లాయీస్ తీసుకోండి, అందులో డిఫరెంట్ గ్రూప్స్ ఉంటారు, మేనేజర్స్ ఉంటారు, హెచ్ఆర్స్ ఉంటారు, అలాగే సేల్స్ పర్సన్స్ ఉంటారు, మార్కెటింగ్ పర్సన్స్ ఉంటారు, అట్లా డిఫరెంట్ గ్రూప్స్ గా డివైడ్ చేయడానికి. ఓకే, అలాగే కాలేజీలో కూడా స్టూడెంట్స్ ని మేలు ఫిమేల్ ఇలా డిఫరెంట్ గ్రూప్స్ గా డివైడ్ చేసాము. ఇలా ఇస్తున్నారు ఎగ్జాంపుల్. డిఫరెంట్ గ్రూప్స్, ఏజ్ కావచ్చు, జెండర్, రీజియన్, ఇట్లా డిఫరెంట్ క్యారెక్టరిస్టిక్ కన్సిడర్ చేసి డివైడ్ చేసి శాంపుల్ డ్రా చేయాలి అంటే అప్పుడు మీరు ఏం చేయాలి? స్ట్రాటిఫైడ్ ర్యాండమ్. పర్టికులర్ గా ఏదైనా ఒక కండిషన్ ఇచ్చాడు అంటే ఆ కండిషన్ ప్రకారం గ్రూప్ గా డివైడ్ చేయాలి, అప్పుడు శాంపుల్ డ్రా చేయాలి. స్ట్రాటిఫైడ్ ర్యాండమ్ శాంపుల్. క్లస్టర్ శాంప్లింగ్ అంటే ఏంటిందా నేను చెప్పాను, డిఫరెంట్ గ్రూప్స్ గా డివైడ్ చేశాక మొత్తం గ్రూప్ ని మొత్తం కన్సిడర్ చేస్తుంటే దాన్నే క్లస్టర్. పాపులేషన్ డివైడెడ్ ఇంటూ క్లస్టర్స్, అట్లా హోల్ క్లస్టర్స్ ని ర్యాండమ్ గా సెలెక్ట్ చేస్తాం. ర్యాండమ్లీ పికింగ్ 5 schools అండ్ సర్వేయింగ్ ఆల్ ద స్టూడెంట్స్ ఇన్ దోస్ స్కూల్స్. ఇక్కడే చూడండి, స్ట్రాటిఫైడ్ లో ఏం చేస్తున్నాం? అందరినీ తీసుకోవట్ల గ్రూప్ లో, ఇక్కడ గ్రూప్ లో ఉన్న అందరినీ తీసుకుంటున్నాం. ఎగ్జాంపుల్ చూసుకుని జాగ్రత్తగా ఆన్సర్ చేయండి. మల్టీ స్టేజ్ శాంప్లింగ్ ఇక్కడ మీకు అర్థమైపోతుంది. ఫస్ట్ సెలెక్ట్ ద మండల్స్, డిస్ట్రిక్ట్స్, ఆర్ ఫస్ట్ సెలెక్ట్ ద కంట్రీ అండ్ దెన్ స్టేట్స్ అండ్ దెన్ మండల్స్ అండ్ దెన్ డిస్ట్రిక్ట్స్, ఇలా ఇస్తున్నాడు అనుకున్నది మల్టీ స్టేజ్ శాంప్లింగ్. ఓకే, కాంబినేషన్ ఆఫ్ క్లస్టర్ ర్యాండమ్ శాంప్లింగ్, రెండు మల్టీ స్టేజ్ అనేది. కన్వీనియన్స్ శాంప్లింగ్, మన కన్వీనియంట్ ప్రకారం ర్యాండమ్ గా కాకుండా ఎలా పడితే అలా తీసుకునేదాన్ని కన్వీనియన్స్. ఇంటర్వ్యూయింగ్ షాపర్స్ అట్ ఏ సింగిల్ మాల్ ఎంట్రన్స్, వాడు ఏదైనా సర్వే చేయమన్నాడు, ప్రతి షాపింగ్ మాల్ కి వెళ్ళమన్నాడు. అలా వెళ్ళలేదు మీరు, ఒకే షాపింగ్ మాల్ దగ్గర నుంచున్నారు, అక్కడే అందరినీ ఎంక్వైరీ చేశారు. అంటే మీకు కన్వీనియంట్ గా మీకు దగ్గరగా ఉంది, దాన్నే అక్కడే తీసుకుని చేశారు. అది కన్వీనియన్స్ శాంప్లింగ్. కోటా శాంప్లింగ్ అండి. కోటా శాంప్లింగ్ అంటే ఏంటి? వాడు పర్టికులర్ గా ఇచ్చాడు, ఇంటర్వ్యూలో నేను 30 మేల్స్ ని తీసుకుంటాను, 30 ఫిమేల్స్ తీసుకుంటాను, అంత మించి నేను తీసుకోను. అలాంటప్పుడు వాడు ఆ పర్టికులర్ మెంబర్ ని మాత్రమే తీసుకుంటాడు. దాన్నే కోటా శాంప్లింగ్. ఇన్షూర్ సర్టెన్ కేటగిరీస్ ఆర్ రిప్రజెంటెడ్. 50% మేల్ కావాలి, 50% మేల్, సర్టెన్ కోటా ఇచ్చేసాడు. ఓకే, దాన్నే కోటా శాంప్లింగ్. ఇది కూడా నాన్ ర్యాండమ్. స్నోబాల్ ఇందాక నేను చెప్పాను, ఎగ్జిస్టింగ్ పార్టిసిపెంట్స్ మళ్ళీ ఇంకొంతమంది రిక్రూట్ చేసుకోవాలి. అట్లా రిక్రూట్మెంట్ జరుగుతూనే ఉంటుంది, ఒకదాని కింద ఒకటి, ఒకదాని కింద ఒకటి, ఒకదాని కింద ఒకటి, ఒకదాని. స్టాలిన్ సినిమా ఎగ్జాంపుల్ చెప్తుంటాను, నువ్వు ఒకళ్ళకి హెల్ప్ చేయి, వాళ్ళు ఒకళ్ళని ముగ్గురికి హెల్ప్ చేయమను, అట్లా 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 పెరిగిపోతూ వెళ్తున్నాను. ఓకే, బిజినెస్ స్నోబాల్ శాంప్లింగ్. సో ఆస్కింగ్ ఏ ఫ్యూ డ్రగ్ యూజర్స్ టు రిఫర్ పీర్స్ ఫర్ ఏ స్టడీ, ఇది స్నోబాల్. అండ్ లాస్ట్ పర్పసివ్ శాంప్లింగ్. పర్పసివ్ కి మనం చాలా ఎగ్జాంపుల్స్ చూసాం. రీసెర్చర్ సెలెక్ట్ స్పెసిఫిక్ ఇండివిజువల్స్ హూ మీట్ స్టడీ క్రైటీరియా. వాడి స్టడీ క్రైటీరియాకి ఏదైతే సూటబుల్లో వాళ్ళని మాత్రమే 1 1 1 2 2 2 ర్యాంక్స్ చెప్పాలనుకుంటున్నారు, హయ్యర్ ర్యాంక్స్ వచ్చిన వాళ్ళనే చూపిస్తారు. ఇదే పర్పసివ్ శాంప్లింగ్. ఓకే, చూసింగ్ సీనియర్ మేనేజర్స్ ఫర్ ఏ కార్పొరేట్ స్ట్రాటజీ ఇంటర్వ్యూ. ఆన్లైన్ ఓటింగ్ బెస్ట్ ఎగ్జాంపుల్, లాస్ట్ అటెంప్ట్ లో అడిగాడు. ఫర్ ఆన్లైన్ ఓటింగ్ which is the sampling design you are using. పర్పసివ్ అంటే ఎవరినైతే గెలిపించాలనుకుంటున్నారో వాళ్ళకే ఓట్స్ ఎక్కువ పడతాయండి. ఓకేనా, మన ఎగ్జాంపుల్స్ చూసుకోండి. ఫస్ట్ పార్ట్ ఇది నాన్న. సో మన థియరీ మ్యారథాన్ లో ఫస్ట్ పార్ట్ కంప్లీట్ చేసాం. ఆఫ్టర్ దిస్ సెకండ్ పార్ట్ కూడా విత్ ఇన్ ఏ షార్ట్ స్పాన్ ఆఫ్ టైం ఐ విల్ అప్లోడ్. థ్యాంక్ యూ ఫర్ కోఆపరేటింగ్. ప్లీజ్ like and share nana. Any suggestions, all are welcome. Okay, thank you all. All the best for your exams.